Okay, so where we left off was we were talking about the fact that absolute value is just the distance from the origin. So when we're speaking about vectors, it's really just the length of the vector. Not worrying about the direction, just the length. So in one dimension, it's easy, just read it off the number line. In 2 dimensions, then it's what we've been doing since grade 11. It's finding the length by breaking it into its components and doing Pythagorean theorem. So to get the length of the vector or the absolute value in 2 dimensions, you would use the Pythagorean theorem. Okay? Which of course you all know. All right. But what about 3 dimensions? Now you all know how to do the Pythagorean theorem, but my money would be on that you didn't realize that you were finding the absolute value when you were doing the Pythagorean theorem to get the length of a vector. Okay, so what about if it's 3 dimensions? So what would you do? So let's test my 3-dimensional drawing ability here. Okay, so it looks way too squared. I didn't really mean it to be that square, but let's suppose this is 4 centimeters. I'm going to say this is 5 centimeters. I know it looks longer. It's an optical illusion. And this is 3 centimeters. And so then the question is, what is the vector, the length, the absolute value of going from this corner figure it out here, to this one. I don't know how I'm going to draw that in, but like diagonal through the thing. Can you do it? Can you figure it out? And I'm going to leave that as just a fun little thing for you to see if you can do. We'll talk about it when you're back in front of me. So if that side's 3, this side's 3. And you might need to think about, okay, can you find it in one section and then another section, okay? I'm not going to tell you the answer yet, because what fun would that be? Just one last little thing, and that is, so number 2 is absolute value, finding the length of the vector. So I want you to find the length of this vector, which is in 3 dimensions. Number 3, and this is where we'll stop, and it'll only take a second. Number 3 is what happens if you multiply a vector by a scalar. And we've been doing this too, we just haven't talked about it. So multiplying a vector by a scalar. Okay, so imagine that you have a vector, and maybe that vector is a vector that's 4 newtons east. East. And you want to multiply it by 3. You want it 3 times as big. What happens to it? You multiply the magnitude and it doesn't change the direction. So what we usually say is that if we let A be a vector and we're going to use the Greek letter A, which is an alpha, be a scalar, then B, which is equal to alpha times A. So if we multiply the scalar by A, we get B, which is a vector. So B is a vector that is parallel to A. Right? Because if you multiply by a scalar, all you're doing is making it bigger. You're just changing its magnitude, okay? And so its magnitude then, B's magnitude, and remember, magnitude or length of a vector is the absolute value, so we can write it like this. Its magnitude would just be equal to alpha, the factor, the scalar you multiplied it by, like the 3, times the magnitude of A, which was 4. Okay, so really all I'm showing you here is the notation of how to write things so that it doesn't get too confusing. I will wait until we're back together in person before we begin to use it. But I know you might need to watch that a little bit again. So all it's saying is, if A is some vector, so in the example I'm saying let A be 4 newtons east. And then alpha is some scalar, and I had said let alpha be 3. So then B, which is a vector, put a little arrowhead on the top, ends up being parallel to A, because if alpha is a scalar, when you multiply your force, it's 3 times as big. It's still going to be east. It's just going to be 12 newtons now. Okay, so B ends up being parallel to the original vector, and its size, its length, is simply 3 times the original length. Now, when it's one-dimensional, this seems easy. Like, the math is easy. When it's more than one-dimensional, you might have to do like the Pythagorean theorem to get the length of A and then multiply that length by 3. Okay? All right, I'm going to stop there. Your only homework over the weekend, or over until I see you again, is the math sheet to finish to hand in, and don't forget your WMIS. Okay? All right, have a good one.